Good afternoon, everybody. Welcome to class today. Thank you for watching, whether you are watching live or you're watching the recording a little bit later on. I appreciate you all taking the time to watch this. Hopefully you all are finding this useful, those of you who are watching it, and I hope it helps you to solve your problems with programming just a little bit better. So we're getting ready to start Module 9, right? We're almost right at the end here. We basically have 2 modules left. We have Module 9, which we're starting tomorrow. And then Module 10 that we're doing after spring break. And then that final week there gives you a little bit of time to pull together your final projects. So we're almost done. So as we are finishing, one of the important things for us to kind of remember is to keep our head held high, finish strong, right? Like this part of the semester is always the most challenging for everybody, really, because, well, like everybody has big projects and big exams and big things due here right at the end of the semester. And then, you know, there's the Easter holiday, and some people do some things with that. Right here at the end of the semester this year as well. You know, there's just a lot of things coming together to try to throw some obstacles in our way here at the end of the semester. So let's just make sure that we're keeping our head up, keep pushing forward. It'll be here before you know it, and let's finish strong. And we are talking about files today. We are talking about files, and in talking about files, there is one key idea that we're talking about when it comes to files that makes this more important than anything. And so based on time constraints, right, I'm going to talk mostly about text files today. You are also asked to work with CSV files. And you'll want to make sure that you are examining the CSV file material that I have built out for you and put into the module there, in addition to this material that you are watching currently. But I think the first thing that we really need to do here is we really need to start with something very, very simple, and that's the idea of just what a file is, right? And this is actually a question that some people will ask to programmers in job interviews. What is a file? Right, and I think we like to think about files in sort of a tangible way, right? You know, a file, you know, we kind of think about a file as a thing, right? Because we talk about files in terms of, hey, open that file, send me that file, you know, do something with that file. But really, a file doesn't really exist, right? Like, it's not really a tangible thing, a digital file here. What it really is a named location on a disk, right? So an addressed location, some kind of named location on a hard drive that is used to store data, information. Right? One of the big things here is that it's used to store data in non-volatile memory, or on the hard drive. Right? So that's a big sort of deal there. Right? So we can kind of think about this in terms of the way that we've been using programs up until now. Right? Because up until now, all of our programs have only existed in volatile memory, have only existed in RAM. Right? But now we're talking about using files, and the question that we might want to bring up is, well, what's the point, right? Why would we use a file? And so as everything we've done now, it's been done in RAM. So when we stop running our program, when we restart our computer, whatever, is relevant there, the RAM empties out. Right? What is temporarily stored in that volatile memory leaves that volatile memory. And so any changes that you made, any data that you added, anything that you might have worked with otherwise, is gone. Right? So what gives then, right? Like, what's the big deal here? We can kind of work with it. We can put that data in there, and we can work with that in that sort of way. But, data is oftentimes, we want data, right? Like, we need data. At the end of the day, like, that's the thing that we're working with is data. So, while it is nice to be able to kind of temporarily work with this data in volatile memory, we need something that can store that data for future use and can keep new data and can do all of this kind of fun stuff, right? So in terms of file use, the big thing there is persistence. Being able to have something that can be saved to non-volatile memory that we can utilize to store data for the long term, persistently, right? Until we need it again or until we no longer need it anymore. And so in order for us to kind of understand this, I think one of the good things for us to understand, because it's going to also kind of deal with the way that we work with data in general, and that's the idea of how memory in a computer works. So as we're looking at this, right, let's see if I can get my drawing screen to come up here. Come on. Well, it looks like that's not going to cooperate. So we'll just describe it, and hopefully you can kind of picture this in your head. Maybe you can write it down in front of you as I'm kind of mentioning it here. But this idea of how memory in a computer works, right? Like we have three parts of the sort of process that utilizes the data, right? So you have your processor, and that's the one that takes the data and runs the process on it, whatever that may be depending on the situation. You have your non-volatile memory, which is your hard drive. That's your persistent storage for data, right? It's the location on a hard disk that keeps that data there. And then you have your volatile memory, and that's your RAM. And so what happens is data goes from the long-term storage, it goes from the persistent storage or non-volatile memory. It gets pushed into the volatile memory, and from there it can go back and forth to the processor to have that data processed. When it's time for that data to be saved, or it's time for that data to be out of use, then we can take that data, we can have it in volatile memory in our RAM, and send it back to our hard disk. Right, so this trade-off, this pass-off from our non-volatile memory to our volatile memory, and then from our volatile memory back to our non-volatile memory, should, influence us in terms of what we're doing here with our file. Because what we'll typically need to do with our file is we'll just take data out of our file. We will load it into our volatile memory. We will do whatever we need to do with that data while it's in volatile memory, which is basically what we've been doing with every other program up until this point, right? And then we just have the means to send it back to our file. And so when we're using a file in Python, we have 3 file operations that we need to take care of. These 3 file operations happen in this order that you see them here. And so when we want to read from or write to a file, we have to first open it, right? And that makes a whole lot of sense. And then when we're closed with, or when we're done with our file, it needs to be closed so that the resources that are tied up with that file are then freed, right? Because we're taking that file, we're loading it into volatile memory, and it's going to sit in volatile memory until we tell it to close that file. So in Python, a file operation takes place in the following order that we have here, right? We're going to open a file, we're going to perform an operation on that file, and then we are going to close the file. And so if we were to look at this in a little more depth with some syntax here, we could look at it in this sort of way, right? Python has a built-in function called open that's going to allow us to open a file. And this function returns a file object. So when we open a file with this open function that we see here, it is opening this file, it is loading it into volatile memory, and it is creating an object with that file. So if it's in the same directory, which is what we'd be doing with replit, we would just do like you see here in this bullet point, where we say open text.test.txt. If you're on your computer using idle or some other text editor and you want to specify a full path to the file, you can do that thusly. And we have 4 modes, technically, that we can specify the mode when opening a file. We can specify to open it in read, write, and append mode, as we have listed here. There's another mode that is X, which is just file creation mode. There are other ways that we can kind of do this, but for now we're just primarily going to focus on read, write, and append. And so we can actually just start to kind of do this, right? So let me pull up my replit window here. Where are you? There you are. Let's go ahead and add our shebang. Hashbang /usr /bin/env Python 3. And we're going to write a function here. We're going to write this function called open file. So let us write this def open _ file. And we're going to pass this a parameter or argument of file name. So if we're just going to open a file here, we probably need to start with a file that we can open, right? So let's create a new file here. We're going to add a file here to our files palette in replit. Add file. And we're going to add a file test.txt. And so now if we click on test.txt, we see here test.txt in the tab, we have an empty file. If we wanted to, we can generate some dummy text here. So let me just pull up a dummy text generator here just really quickly so we can get some information here that we can use. We'll just let an AI create us some dummy text, and we'll put it in here, thusly. And so one of the key things to note here is just how this file is laid out, right? Like what's going on in this file. As we are dealing with files, data, writing data and reading data to files, we want to kind of pay attention to the formatting of our files. So in this instance, right, I see I have essentially 3 lines here, right? We can tell that by the numbers that go down the side. 1, 2, 3. 3 lines. That's a line. That's a line. And that's a line. So now I have this file with this text. So I want to open it. And I want to open it in read mode. We'll make sure to put that file name in after we write this function and we get our main gate in there, right? But I'm going to open whatever this parameter file name is. So I'm going to create a variable called file. We can call it whatever we want to call it. But this is called file. It's just a variable, right? And we're going to set it equal to open whatever our file name is in R mode. Right, and so that's going to create a file object, an open file object, utilizing whatever our file name is, right? We're using the file name parameter here so we can include the file name when we call our function. This will open the file and put a file object into our memory, into our volatile memory, right? So when it's just sitting here in our files palette, right? It's in non-volatile memory. It's on a more permanent bit of storage there. So whenever I, refresh this replit, that file with that data in it's still there, and it's still going to be there forever and ever and ever. So let's put a call to this function behind a main gate. So that's if name equals main. We are going to call this function our open file function with our test file, which is test.txt. And now, just to see what this does, what I want to do is I want to print the resulting object that I get from file, so we can see what is located, or what this in particular does. Right, so when I run this, it's going to open the file, create an object with that file, and print the result of the object. And we see it there, right? This is an IO text wrapper object. It's just saying that we're getting this input from a text file. It is an object. It is in read mode. Its encoding is UTF-8. Right, so we have to do a little bit more with this file to be able to actually get the data out of it. And so what we would want to do here is we'd want to actually read this file. So we've opened the file. We've created an object here. We've opened the file. We've put it into volatile memory out of non-volatile memory. And now that we've opened it, we can read it. So in this case, what we want to do is we want to create a new variable. We'll call this one read file. And we'll set that equal to read lines. Actually, I'm getting a little bit ahead of myself because I need to actually put the file that I'm reading first. File.readLines. And so this is going to create a list of all the lines that are in my file. And that's one way that we can do this. So now if we print out our read file function, we can see the results there. We get this list of all the lines in my file. Now, one of the things that you see here is that at the end of every line, we have this /n character, right? The slash, which is the slash above the enter key, and the letter N that's in the end of my lines. That's basically a return character, right? That's like pressing enter at the end of the line. So if I'm going to use this data, what I have to do is I have to go through and sanitize this data, which makes things a little bit difficult for us, right? Because essentially what I would need to do is, now that I have this data in a list that's in our volatile memory, I'd have to iterate over this list and remove those last two characters from every line that's not the last line, because the last line doesn't have those characters on it because there's no enter after the last line, right? There's no line 4 underneath. So what I'd want to be able to do here is I'd want to be able to write some kind of conditional to check to see, as we iterate over this list, what we're doing here, right? So, or if those characters are present. And so ideally what we would do here is we would just do a bit of a string slice. What I can do is I can create a new read file clean, which is an empty list. I can write a for loop that will iterate over this file. So for I in range 0 to the length of the list, so the length of read file, I can check a conditional to see if I is this last index location, right? So I can say if I is equal to len read file minus 1, right? And why do we want to subtract 1 from the length? Because remember, this is just a list again. This goes back to all that list information from a couple of modules ago. Our list, the length of our list is a certain number, right? So in this case, we have 3 lines. So the length of our list would be 3. But if we were to look at the index location for each of these lines, we start counting our index location at 0. So the first line would have index location 0. The second line would have index location 1. The third line would have index location 2. So if it's the last index location in my list, which would be the length of the list minus 1, I can just append that item straight up. So I can say read file clean dot append read file at index location I. Otherwise, I want to slice off those last 2 characters, which would be read file clean dot append read underscore file at index location of I. String slicing, if you'll remember back to our string manipulation, everything up to but not including those last 2 characters. So I would want to slice everything up to here, which is the slash. So it would be the length of the word minus 1. So that would be colon len read file I minus 1. And then all this does, right, is just going to sanitize those new line characters out of this file. Because when we're working with our data and we're changing our data, checking our data, right, we might be looking, for example, the word doesn't here. Or, we might be doing something with our text if that's the case, right, we want to be able to make sure that everything is, nice and clean to where we can understand what we're dealing with so we can work with it. So now if we print our read clean file, we can see that it no longer has those /n's at the end of it. And we can look at those side by side, right? And we can say print read file versus print read file clean. So the first one here still has the /n's. We see here the last few words in this first object this first element rather, is subdo air divide doesn't /n. And we see here subdo air divide doesn't with no /n at the end, right? So all we did there was just clean that file to remove those /n's. Now there's another thing that I can do here that's going to make my life a whole lot easier. Right? So this is something valid that we can do. But there's something else that we can do with this where it would be a little bit easier to work with this data. And that's to just, as we're reading our file, instead of reading all the lines, if we just read the file completely. Equals file dot read. So now let's print read file and see what we end up with here. There's our text. And so one of the things that we notice about this text, right, is that, one, it doesn't have those /n's, right? So we don't have to worry about that. Although there might be some issues here because of the fact that, it is just a singular thing now, right? It's not a list anymore. It's just essentially just a singular string, right? However, let's see what we can do with this now, right? So if we just printed a for loop to iterate over this thing here, we could kind of see what we're working with, right? So for I in read file, we will print I. And this will just give us an indication of what's going on here. And we can see what happens there, right? It's just a singular string that we're working with. But since it is a singular string, when we iterate over it, we end up with all of the singular characters in our string. So if we're looking for, say, substrings or something of that nature, we could use some of the string manipulation techniques that we learned about in that module. Right? For example, we learned about the find function. So if I wanted to find a particular word in read file, let's just find one maybe that's in here. Let's try to find the word deep, because we can see deep's in here twice. I can use my find function to find a substring, and that will give me a count of how many times that substring appears in this string. Or actually, it'll give me, no, it doesn't do that. It gives me the location of where, it gives me the index location of where that substring occurs. Right, so that will let me know if it's in here at all. And we see there, it's at the first instance of the substring deep is at index location 127. So we can start to use this string like that. Just to see if a substring is in here. However, that's not going to do very well for us if we're looking to count how many words are in how many singular words are in our string, right? How many instances of a substring appears in our string. Right? We can do some fancy iteration there to try to find a sequence of characters, because a string is just that. A string is just a sequence of characters that we put together. But what we could also do here, right, is use a structure that we talked about previously to change this into a list. Right, so we can actually use a split here on our read file here. So this will take it and create a list, or this will take it and create a string rather. This will take and split that string into a list based on a delimiter that we provide, say a space. And then we would have a list that would have every single word segmented out in it. Now, in our example here, we're seeing some issues, right? Like we're still seeing this /n. If we wanted to split it based on lines, we can split based on that /n. So if I have multiple lines in my file and I want to split my lines into different list items, I can do that. Right? And so now I have different list items, these different lines as different list items, and that /n isn't in there because that's what I used to split it on. So as we can see here, this right here does the same thing as this right here. This is just a little bit cleaner than this. And so from here, if we wanted to, right, like this is a little more this is a little tougher to deal with than some of the other things that you're given, right? Because this phrase in particular has more characters in it, right? Things that we'd have to deal with and clean, right? If we were going to say iterate over this and try to figure out our substrings, right? So let's just do some cleaning here. We can just work with some simple cleaning and try to clean this file. And I'm going to provide you all some other information as well from some other things, just so you can have as much as possible to work with here. But what I want to do is I want to iterate over all of my list items in read file. So for I in read file, so for each of my list items in read file, I want to do a little bit of cleaning, right? I want to get rid of every period. I want to get rid of every comma. So on and so forth, right? So and that's all I think I want to get rid of. So for I in read file, every item in this list is just a string, so I can use my string manipulation functions here to start to sanitize this to where I can iterate over it. For I in read file, I can just say I.replace comma with an empty space, I.replace the period with an empty thing, right? It might be smarter for us to kind of take this and put this in just a little temporary variable here. So we can say temp equals, and then we can replace this in the array maybe, right? And we can just say I equals temp, you know, something like that. So when we were, so if we were to run this now into, we might have to change this a little bit, right? Because I'm not sure I wrote that correctly. I'm kind of doing a lot of what I'm doing today on the fly. We can print read file here. And yeah, that didn't work the way that we wanted to. Yeah, we should probably do this. Do this with our range. Because when we're referring to this here, we're referring to the string itself instead of the item in the index location. So we probably need to iterate it over it this way instead. So it would be read file at this index location dot replace read file at this index location dot replace and read file at this index location will now equal, actually we could call this like temp2, and then we could say temp dot replace, and then we'll just equal that to temp2. Right, so now when we were to print that, that's better, right? There are no commas in these words, there are no parentheses or periods in these words, right? So now if we are looking for a word in here, we can start to look through these things even more. Another thing that we could do here is subdivide all of these items as well. So we could create a 2D array of all the words. Right, another option there would be to do that at the string level, right, which would probably be a little bit smarter. Probably be a little bit smarter if we did that. So we didn't have to work with a 2D array. We could probably make a little function called a sanitize file. Let's do that instead. Def sanitize file. And we are going to pass it the file array. And we are going to return san file. Right, but all we'll do is we'll take, we'll essentially take this part here. I want to work with this as well. So we'll move this to my sanitized file here. We'll take our, so now instead of read file, this will be file R, because it'll be whatever we bring in as the parameter here. Actually, we would essentially return because then we would say file R at this index location would equal temp2. And yeah, this is actually, yeah, so it won't be an array coming in, it'll be a string, right? It's the singular string coming in here. And so what we want to do is we'll load it in. So we actually won't need to do this for loop now. I'm sorry, everybody. Let's figure this out together. And we can also take a temp3 and set that equal to temp2 dot replace and get rid of the /n characters this way as well. And so now we can say san file equals temp2, but it'll be temp3 now. And we also wouldn't need this either. And so now we'll be returning the sanitized file. So now in this case, we would have all of this gone. And we would set a new variable, clean file, equal to sanitize underscore file with read file in here. And now we're going to print clean. And we can also split this on spaces. So we can split every word. And so now we can print clean file. And that will give us every single word without any punctuation here. We are, in our, where the lines broke here, we probably need to replace that with a space instead of a nothing there, because we can see there doesn't and don't run right into one another, right? So we can do that, and that will split them up when we get back to here. And so we did all of this. We had to do all this stuff here with our temporary variables, because if you'll remember back, strings are immutable, so we can't change strings in place. We need to pass them to another temporary variable. And so now we can search over this, right? Find a word. And if that word is present, we can add to a little counting variable. So for example, what I could do here is I could return clean file. We can write ourselves a find word function. And we can just pass this clean file into it. So it will be some kind of array. We'll call it clean array. Take an input from a user. Word to find equals input equals an input of enter word to find. We'll have a little occurrences variable set to 0 for I in clean R. If I equals word to find occurrences plus equals one. Right, and then at the end of this, all we'd have to do is return occurrences. So now we can load a file. Right, we're loading our file here. We're sanitizing our file. We're taking out all the periods, all the commas, And we are putting it into a data structure in our volatile memory that we know how to use, which is our list. Now we've created ourselves another array that we can use to go through this file and look for a specific word. And so now what we would want to do is we would want to we'd want to print find word with the argument of open file on test.txt. Now the word that we were going to be looking for previously, I believe, was deep, correct? So now, unexpected into field while parsing. What did I do? Says it's on line 47, so it's here. I need another parenthesis. Enter word defined, which was deep. And there are two occurrences of the word deep in this file. So what I'm doing for you here today kind of took a turn, right? Because I kind of decided just midstream to throw what I had planned in the ditch. I'm going to provide for you the seeded class videos as well as this video to show you this. But this is just one of the ways that we can go through a file, use a file that is stored in persistent memory, take and sanitize the data that's in that file in volatile memory, and work with that file in volatile memory. So I'm going to give you this file. I am going to give you 2 videos of the seeded class lectures that we've done previously. And that will be what I give you for material for this module. So this is all I'm going to give you for this video. Right, so we're going to go ahead and stop here. We'll turn on the music for just a minute. Let that go, just in case anybody who's here with me live has any questions. Thank you for watching. We'll see you next time.